Welcome to some background information on how to use anchoring phenomena to develop science instruction. Listed below are the learning objectives for this assignment. Important thing to consider in this task is, what is a phenomena? What is described here, a phenomena is an observable events in nature or our lives that connect to multiple NGSS core ideas. Examples and some of the reading for you. It offers the example of finished snow trees or the behavior of bees. The goal then is that throughout a unit, a student is going to work toward explaining the science concepts behind the phenomena in their own words. It doesn't matter what grade or subject they're with, the same phenomena can be used across K through 12 learning with different focus for each level. A question that you might have developed at this point is, how can phenomena be used, or why should they be used? Well, first of all, it helps if we can look at this in kind of 3 steps. First of all, the point of the phenomenon is it provides a context, a reason, or a point of engagement for a unit of study. It helps the students to generate questions. You might find in some of the curriculum materials you use that a unit already starts with a set of guiding questions, and that's in fact a valuable practice. However, by using phenomena, students are asked to generate their own questions and make sense of what they observed. This is a more intellectually rigorous practice, and it also is more personally compelling and engaging to the students. Finally, answering questions helps them explore the next generation science standards, and the questions answered by the students help them master the points of information that are covered in the unit. I provided you with a link to a number of examples and pulled out 3 here just to take a look at for our purposes. Biological weathering, phototaxis, colony collapse syndrome with bees are 3 points of interest among many that can be used to guide instruction for science. In the example of phototaxis, researchers suggest that only young sunflowers will follow the sun. These flowers are believed to follow a natural rhythm that receive the most light to help with photosynthesis. So this observation generates questions as to why they move and what can be learned from that. Notice that the standards are not just a single one, but multiple standards. So this can be used all the way through the school system, but to use it to meet the purposes of different student learning needs. An important question that we might have is, where do we find phenomena? And that's of course an excellent question. Sometimes phenomena come from the lives of students. The example shown here is a photograph of a food can that's swollen. The question might be, what caused that? What's the consequences of eating the food that might be in the can? Is that something that happens to all foods? These are important considerations, and there's great science behind that could be used as a point of departure to explore, starting with the can of fruit. Other materials, you might have a curriculum that makes use of this phenomena to start with. Of course, that's an easier solution for you because the phenomenon is already provided. However, this task will help illuminate for you why we use phenomena and the importance in making use of them. Last possibility is what teachers often do is they will find solutions themselves, and there are teacher-curated resources that will be very useful in this task. The assignment directs you to a set of teacher-developed resources, and that'll help you select a phenomenon that's already been identified that works well with developing questions and is also already aligned with a set of standards. I've identified 3 basic steps to complete this assignment. I hope that you find it to be just about as simple as 1, 2, 3. The first 2 steps are straightforward. It's just to identify a phenomena, and that's available through the resource documents that are provided. This one's labeled Resource 1. And then each of those phenomena have an NGSS standard. In some cases there's 1 or more. Just ask you to pick one that seems to make sense for the grade level you're interested in working at. Finally, the next step is to just develop a description of the relationships between the phenomena, the standard, and the questions that can be generated that students can answer. We have a question about what an example might look like. There's one available to you on Canvas. I'd like to just take a few minutes in these slides to describe what the parts of it are and how they fit together. First point to include is a description of the phenomena. In this case, I'm describing using student observations of the phases of the moon and the angular distance between the sun and the moon. In fact, this is one that my intention is that we do it in class. If you use the course's resources and use some of the teacher-developed materials, you might also include a video here as well as a description of it. Next is the rationale, which is basically a statement of why this phenomenon was used to develop instruction. The next point is to connect the phenomenon with the next generation science standards. There's no student or professor generated content here. I simply recorded what the standard is that can be connected with the phenomenon. So I've identified the standard, and then the science and engineering practices, the disciplinary core ideas, and the cross-cutting concepts. Starting at the bottom of the left-hand page, continuing to the top of the right-hand page, some sample questions that students might ask. These questions could be fairly straightforward, thinking about them from the point of view of young people. So simply, what's the relationship between the phases of the moon and where the moon and sun appear in the sky? The relationship between the unit and the questions is critical here. The two questions that are listed below about what the students will do to answer the questions is what's going to help them make sense of the next generation science standards. So again, the selection of the phenomena becomes important because it helps generate the questions that will address the content of the standards. And finally, at the bottom of the page here is the assessment. So please keep this rubric intact when you submit the assignment. It's formative in nature, so it's designed to help you make sense of things. It's not for heavy and consequential course grade, but to give you feedback as you're developing some ideas. So please include that in your final submission. Just a learning theory sidebar on the importance of this approach. We want to have a reason why we do these things, and here's some points that I think are important to consider. In the right-hand column, there's a column that describes high-level cognitive demand and procedures with connection tasks, and some elements of what that looks like, and the opportunity for students to engage in higher levels of inquiry and what that looks like. What we understand is that activities that use connections among ideas, that place emphasis on using procedures to solve problems, these help students develop deeper understanding of science concepts and ideas. So it's not just following a series of steps to answer a question, but it's really suggesting pathways for students to follow as they build their own understanding. These tasks that are called high cognitive demand tasks, they help students that make these connections. It gives opportunities to analyze information and to draw conclusions. By students generating their own questions, that's a more productive pathway to giving students these tools to become problem solvers. In closure, I hope this provides a little bit more clarity and context for this assignment. Please follow with me during class or office hours if you'd like some further guidance. Please also make sure you look at the example that's provided and the other course information about this assignment that's on Canvas. Thanks a lot. I wish you well as you complete this.